save money and time. I told you many times it would not work, and it didn't. It's your fault. No. You are the one who did not listen to the master. You are the one who come up with this stupid idea. Let's keep the database intact.
Guys, enough. Did I ever tell you all you need is microservices?
You believe all you need is microservices.
Yes. Did I?
Well, that is unfortunately not entirely true. You still need to learn two concepts if you want to leverage the power of microservices. No.
Thank you. Stay calm, relax, and let's continue. Listen to the master.
Microservices architecture is often implemented with software design patterns like CQRS and event sourcing.
CQ what? Event sourcing? We don't have any events.
Idiots. Of course we don't have events because we designed everything in a traditional way. But this is something what we want to change or not?
Yes.
Good. Then let's continue.
But what is CQRS? CQRS stands for Command and Query Responsibility Segregation. Most applications have different data access patterns in terms of read and write. CQRS is a design pattern that separates the data modification, the command, and the retrieval, the query aspects of the system. Commands are responsible for updating data and queries for retrieving it. These separations allows the optimization of data read and write operations independently, enabling performance improvements. CQRS allows the use of separate databases with completely different technologies for the command and the query aspect of the system.
I still don't get it. Why it is good?
Sometimes I don't understand, guys, why I'm paying for you.
Number 1. Scalability and performance. The separation of read and write responsibilities allows you to scale these components independently to handle uneven loads. You can design the query side for efficient high-performance read operations, enhancing user experience. Number 2. Flexibility. CQRS facilitates using different data storage technologies on the query side, which can be particularly advantageous for read-heavy applications. You can use, for example, an RDBMS for commands or writes like PostgreSQL database and a separate document database like MongoDB for the query or read part of the system. Number 3. Adaptability and single responsibility. The data representation of read and write are significantly different in most of the systems. CQRS allows for having separate models for both. Changes to the read or write side can be made independently, making it easier to develop the system to meet changing business requirements. Separating read and write logic can lead to cleaner, more maintainable code as each side has a single responsibility. Number 4. Security. CQRS allows for distinct security configurations for read and write operations, helping to protect sensitive data.
But what is event sourcing?
Good question. CQRS indeed difficult to implement without its friend, event sourcing.
CQRS is often used in conjunction with event sourcing to manage data updates through events. But what is event sourcing? Event sourcing is a data storage pattern in software architecture where instead of storing the current state of an object, all changes to the data or entity are recorded as a series of immutable events and saved into an event store. Each event represents a specific state change or action that has occurred in the system.
Okay, I'm confused. We capture these events somehow and use those to recreate the states. Besides, this is a lot of work. Why is it good?
So let's look at some benefits of event sourcing. Number 1. Historical data auditing. Event sourcing provides a complete history of all changes, allowing for detailed auditing, debugging, and analysis of how data has developed over time. Number 2. Temporal queries. The event log enables querying data at different points in time, which is valuable for historical analysis and recreating the state of the system at any given moment. Number 3, scalability and performance. Events are immutable objects and simply appended to the event store. There is no update or delete operations. They can be processed asynchronously and independently, allowing efficient scaling and improved performance in systems with high event volumes. Number 4, debugging and testing. Events make it easier to reproduce issues and test the application's behavior by replaying events or applying them in a different order. Number 5, flexibility, evolution, extensibility. The event log can be used to implement features like undo, redo functionality, providing users with a powerful way to navigate and manipulate data. New features and changes can be introduced by defining and producing new events, making the system adjustable and extensible over time. Number 6, integration and collaboration. Event sourcing is well suited for integrating systems, sharing data across services, and collaborating with external partners, since it provides a standardized way to record and communicate data changes in the form of events.
Master, can I ask something?
Sure.
I understand these concepts one by one, but I don't see the whole picture.
Let me explain this.
We have to escape to a secure place. I will call you from there and explain the event-driven architecture, and then everything will fall into place.